All right, hello. Thanks for being here. You saved the best for last because you're going to know how to build your first AI voice agent. How many of you have been building voice agents? Oh, okay. A few of you. Excellent. Well, let's start. There you go. First of all, we need to know what is an AI agent, right? Because if we're going to build it, we need to know. So if we want to get fancy, we can say it is a piece of software, which is made of two components, a model and tools. And these components work in a thing called the agentic loop. So how does it work? The user makes a prompt, so it invokes the agent, and this goes to the model processes, and it says, with the knowledge I have, it is enough to make a good answer for the user? Maybe not. So if not, what it's going to do? Execute some tools. Which tools? It can be like read documents, fetch information, go to an API. It doesn't matter, right? So with these tools, then you return a result, and you return a final response to the user. What about voice AI agents? It's the same thing we saw, but the interaction is with voice as input and as output. And other characteristics are that, well, voice in and voice out, and we also use a model, and it's a real-time interaction. So in order to build a voice AI agent, we have two architectural approaches to make it. The first one, it is called the voice agentic pipeline, in which you have these decoupled components, which are first the ASR, that is the automatic speech recognition, which is you say something to the agent, and then the transcription does the magic. So from voice goes to text. With this text, you can receive, like the LLM receives this text in order to process a response, and then it goes from text to a speech. So these are the three components which are decoupled, and you can pick the most accurate for each of them. And then we have another architectural approach, which is the speech-to-speech, in which you have all inside like in one neural network. So you cannot enter to the components we saw before. So this gives you the advantage that is more natural because you have less latency, but you have the trade-off that it gives you less control. So if you have an error and you want to debug it, it is harder in this case. So other components, to orchestrate them all, we have to first the audio capture. And this is done thanks to this protocol called WebRTC. Then we have the voice activity. We need to detect when the user and a real voice starts and when it ends, right? And then with the speech recognition, we do the transcription. With this text, the LLM receives it, or maybe it could be a foundational model, right? And then we can add some tools to this response, right, to have it more complete. And then when we have the complete response for the user, we then, with text, we put it into audio, and then all of this, it is orchestrated in real time. So you can see it like this. In this diagram, you have the agent as a server, and all of this is happening underground. This is where the magic happens, and you have to detect all the terms, then do the STT, the LLM, and the TTS. And how can you do all of this? Well, thanks to Pipecat, that is an open source framework that gives you all of the components that we saw already done, and you just have to invoke them and use them. So you can connect the LLMs, the STT, and the TTS into a single pipeline, thanks to Pipecat, right? And it gives you real-time audio and video transport already built in. So you have the input, the audio validation, you can use the model provider you want, and you can build all of the agent, thanks to Pipecat. So if you want to build your AI agent, you need to know some practices to have in mind, right? The first one, and is the key, you need to optimize the latency. Because with latency, your voice AI agent will die. You won't hear it, and you don't want that. So every millisecond you can optimize, it compounds across the conversation. Then you need to pick an efficient model. You need to pick between the size and the quality of the model. Maybe you can pick a smaller one and to have a good enough answer, right? Then you can use prompt caching if you are doing like some rack to have less latency. And you need to ensure clean audio input. You cannot be in a party and try to use your voice AI agent. And then you need to build incrementally, right? You need to first build the starter pieces, make sure it is alive, and then you can add more information, more context, and it will be working. Also, the evaluation and monitoring is key. You need to know what is happening per turn, so you need to monitor the latency per turn. Then you have the functional correctness. It is that you need to know if it is following the instruction of it is hallucinating, if it is doing the thing that you want or not, right? And then in the case of voice AI agents, you can have them to detect speech errors or pronunciation errors. There are some models that give you these capabilities. And also, you need to manage all the context and the memory. So this is what it looks like, the code with Pipecat. You have the pipeline with all the components we saw. You build a transport layer, you invoke a foundational model, and you can also add more things if you want. You have a task, and then also in this case, I am invoking the Amazon Nova Sonic model to interact with the AI agent. And also you can add tools. In this case, we have like a search of stories. I have like a database full of stories, and I want to speak with the agent about these stories. So when the model is processing the information, I can add these stories, so it will have more context, and the response will make sense. And then I will show you the video. This is a voice AI agent I built that is called the English-speaking body. So non-native speakers can improve their English skills abilities. And this voice AI agent detects also pronunciation errors and grammatical errors. So this is what I'm going to see. And also, I am speaking with it about some stories I put in the context. So that is what you're going to see. Oh.
Hello, how are you?
Hi there. I'm doing well, thank you for asking. I'm here to help you improve your spoken English. Let's talk about a story you've read. What did you think of the characters and their journey?
I liked the Agatha story, but I think Agatha are a bad person.
There is an error.
Good thought. It's interesting to think about why Agatha might be acting that way. Maybe she's feeling a lot of pressure with the lead role. Can you say it again, but this time, let's say Agatha is a bad person instead of Agatha are a bad person.
Oh, you're right. So, Agatha are a bad person.
Great try. We say Agatha is a bad person instead of Agatha are a bad person. Can you say it again?
Oh, yeah, sorry. Agatha is a bad person.
Perfect. You're getting better at using the correct grammar. Let's keep talking about
What
the
do
story.
you think about what happened at the coffee shop? I don't remember what happened at the coffee shop.
That is another story, different one.
That's a great question. Let's think about it together. In the coffee shop, Sarah meets someone she recognizes but can't remember who they are. This person turns out to be Jamie, an old friend from her hometown.
I think sometimes I got problems
Well, there, I wanted to test it,
recognizing
driving it
people,
crazy.
persons.
That's a common experience. Sometimes our memories can be tricky, especially when we haven't seen someone in a long time. It's interesting how our brains work. Sometimes we recognize someone's face, but can't place where we know them from. Let's try saying it again, but this time, let's say people instead of persons. It's more common to say people in English.
Oh, okay, so it will be sometimes it's difficult to what should I say?
Testing the model.
Sometimes it's difficult to remember where we know someone from. It's like trying to catch smoke with your hands. The memory feels
Okay, so it will be sometimes it is difficult to remember people.
Perfect. You're getting better at using the correct grammar. Let's keep talking about the story. What do you think about the other characters? How do they react to Agatha's behavior?
I think they is nice.
Another one. Let's see.
Great try. We say they are nice instead of they is nice. Can you say it again?
They are nice.
Perfect. You're getting better at using the correct grammar. Let's keep talking about the story. What do you think about the other characters?
I think I'm done practicing today.
Great job today. Your pronunciation is improving. Keep an eye on word endings. And your grammar is getting better too. Keep practicing and you'll keep getting better.
Okay, thanks for the tip.
You're welcome. I'm glad I could help. Keep practicing.
How would you rate me out of 5 stars?
I wanted more feedback for this session.
I would give you 4 stars. Your answers were mostly clear, but there were a few grammar mistakes and some pronunciation issues. Keep practicing, and you'll get even better.
Thank you.
And how does that work? The video continues, but that is like another part in which I uploaded another PDF, like a story, and I wanted to know if it will take it in the conversation right away. So let's see. I made this story based on Pearl Jam songs. Yeah. There is loading. And then I will start the conversation to talk about that story that wasn't in the database before.
Hello, how are you?
Hi there. I'm doing well. Thank you for asking. How about you? Let's talk about a story you've read or heard. What did you think of the characters?
There is a new story. I don't remember the name. It is called The Color of Something.
That's a beautiful story. Let's talk about the girl in it. What did you think of her?
But what is the name? I don't remember.
The story is called The Color of Her Walls. It's about a girl who expresses herself through painting her room in bold, unconventional colors. She feels misunderstood and isolated, but her art is her way of communicating her inner turmoil and emotions. What did you think of her story?
Oh, I think doing that is very dangerous. How do you say that word?
The word you're asking about is dangerous. It's pronounced dangerous.
And
Let's try
there's a
saying it together.
pronunciation
Dangerous.
skill.
Dangerous.
Great job. Let's keep practicing. How about we talk about the story's ending?
I think it's great.
That's a wonderful thought. The ending shows how Sarah found a piece of herself that she had lost.
All right, thank you. I think I'm done for today.
Enough.
Great job today. Your pronunciation is improving. Keep an eye on word endings. Your answers were mostly clear, but practicing linking your words a bit more will help them flow better. You're doing well.
Well, that was it for the video demo. Now we go with the magic of Elizabeth.
Thank you so much. First, before to start, I want to say that super proud of Camila because all of this is her work. I like a co-pilot here. So Camila, thank you so much. Thank you so much. I'm super proud for you. Yeah, Camila was my mentee. I'm super old. But yeah, I'm super proud of you. So yes, this application that I just saw here is a prototype. It's something that Camila showed you in her computer. But what happens when we want to move this application to production, when you want to deploy that? You need architecture, you need performance if you want that, you need scalability, you need security, governance, because you have a bug. And what happens when, 1,000 users hit your application? You need scalability. So for that, us on AWS, we have a service that we call Amazon Bedrock Agent Core. This is a service like a little pieces of Legos that you can use together or separately. And you have runtime where you can put your code. There is a container that can live up to 8 hours. So you have all the conversation there. You can talk with this container for up to 8 hours. And this is something that is kill me. So you can use that container, you can put the framework, all the code that you want. And this container is going to manage your memory. And the memory is built in. Yeah, that's the problem. Wait. Are you almost there? Okay. And the memory, you can put the memory as a built-in another piece of Lego that you can use with runtime or without runtime. And you can call this memory as an API call. And when I say memory, I'm talking about short-term memory and long-term memory. Long-term memory is a built-in vector database that is completely built in for you. You only need to send your data for that vector store, and there is some LLMs that are going to understand your conversation, and that they are going to build your vector store from the memory. And then you can call this API to do the retrieve. We have built-in observability inside all these little pieces of Lego that you can only see. You don't need to build anything because the observability is completely built in. We have identity, a lot of stuff there. And because we want to build something that you can use, what happened with this? The application that Camila just showed you, we put that in a deploy. Is completely in production inside this agent car. So in a moment, I'm going to show you a link. So you are going to test this application. I hope it doesn't fail, but you can test that. You are going to have authentication using Amazon Cognito. For this application, you are going to send your audio. The audio is going to receive your conversation, is going to have this text input. With this text input, we are going to build the memory, because we can build memory with audio. So we are going to build the memory. Then you are going to have a database for the short-term memory, because we have a short-term memory that is the conversation that you have, and you have long-term memory that is your past. That's the reason why some agents are capable to remember you. So when you close the session, this agent is going to be capable to remember you because this application is having long-term memory. And you are going to have the AI teacher agents. Agent is only code, but this application is a teacher agent because it have the prompt that say you are an English teacher and you are capable to do all the things, everything. And in this application, you have a history catalog with about 30 history, I don't remember how much, but there is a lot of history in a knowledge base. So when you start to talk with this agent, if you ask, please give me a history that I want to read, this agent is going to do the retrieve for this knowledge base that is in Amazon S3 vector store. And he's going to do the retrieve, he's going to give you the history. And you can read the history with this agent. And when the session ends, the agent is going to remember you. And this is the application, it's super awful. But if you are familiar with AWS, this is the service that we are using. So we have Amazon Cognito for the authentication. We are going to share this. We have a QR code at the end of the session, so we are going to share everything that we just talked about here. All the repo, all the PDF, everything is going to be in a link, so you don't need to take pictures. And if you are familiar with CDK Kit, what is it? Cloud Developer Kit, this is infrastructure as a code. You are going to be able to deploy this application with one single line, CDK deploy. And if not, you are going to have the code right there, and you can use your assistant and say, I want to deploy this, and yeah, it's going to deploy that. But everything is there. And this is the application. Enjoy. And is this fair? Please tell me. Let me give you a moment. If you are concerned, I don't going to use this email because he's going to ask you an email. I don't going to use that, okay? I'm going to delete this application tomorrow with all the emails. I give you my word. I don't going to use your email, okay? I don't need that. I only want that you test this. So please, you are safe. I'm going to delete everything. You are good? Take a picture. You are good? Okay. And wait, I need to share you with this. Oh, nice. So, this is the application. Probably because you are seeing this in your cell phone, you're not going to see the conversation history. But if you open this, probably you are going to see it. Let me see if we can test this. Internet.
There you go.
Hello, hola.
Hello! Nice to see you again. How can I help you practice your English today? Would you like to hear a short story?
Yeah, sure.
I found some great small talk phrases and questions for you. Would you like to read this aloud together and practice?
Not today. Thank you. Bye. But if you want, you can do it. So close. And because we are almost on time. Sorry. What? Oh, it's not moving. Thank you. Thank you so much. Please. She is the creator of this.
Well, you can reach us if you want to build your voice AI agent. Let us know. Thank you.
Oh yeah, I'm a developer advocate on AWS, and my specialty is agentic application. So everything you need, I'm there.
Okay.
Oh yeah. Some question for Camila.
Or for Elizabeth.
Hi, amazing presentation. I absolutely loved it. A quick question. For someone who's just getting started with this, what would you say are, to either of you, right? What would you say are the easiest parts to figure out and which are the more complicated steps? Definitely putting it in a production is going to be more complicated, but even in general with building a voice agent application, which is easier, which is harder, what should we keep in mind, what challenges can we expect? But thank you, love the talk.
Thank you. Well, I think the easiest part will be choosing the model provider, because everyone has their favorite and invoking them on the code. But when you try to run all the pipeline, and then when you talk and you don't receive a response because of the latency and all the stuff, managing all the pieces, that is the hardest part. And sometimes that happens when you're building and it doesn't answer, or maybe when the agent doesn't let you speak because he's talking and talking and talking, that happens. So that is the easy part, no, the hardest part. Yeah.
But you can solve the problem with the agent talking with the prompt.
Yeah.
Because, when, for example, with Nova, you can say, hey, stop, and the model is going to stop. But sometimes it's talking, but you can manage that with a prompt because, at the end, the model, it have a prompt. So you can say it in the prompt as a question, stop, receive the answer, and then continue. So you can manage that.
Yeah. You need to create a good personality. Yeah.
Another question? No? Thank you.
No, thank you.